Hi there. Let's go over chapter 9.2, solving linear equations by elimination. Example 1. Rahim goes to a grocery store and spends $22 to purchase 3 cartons of strawberries and 2 cartons of raspberries. Paul goes to the same grocery store and spends $41 to purchase 4 cartons of strawberries and 5 cartons of raspberries. What is the price of 1 carton of strawberries and 1 carton of raspberries? So the table is provided to you, so let's fill in what we know. We know for Rahim, the total amount he spent was $22. And for Paul, we know he spent $41. Also, when you look at the column over here, it says money spent on strawberries. So they don't really care how many cartons of strawberries you purchase, but they just talk about how much it was cost-wise. So let's take a look. So if we say, let's state that S stands for price of 1 carton of, a carton of strawberries, and R for same thing of raspberries. We can actually say Rahim bought 3 cartons of strawberries and 2 cartons of raspberries. Same thing for Paul. This would be 4S and 5R. Alright, so let's state our first 2 equations. All we have to do is add the first row. So for Rahim, it would be 3S plus 2R equals 22. Okay, so essentially what we're saying is that money spent on strawberry plus money spent on raspberry must equal to total spent amount. Okay, so that's first equations for Rahim and Paul. We have 4S plus 5R equals 41. So to solve by elimination, we do need to align the variables. So what I mean by that is that we have the first equation here and the second equation here. S as a variable lines up, same with R, and then the constant also needs to line up as well. Okay, so that's what I mean by align those equations so that they have this common term, like terms together. So in order for us to remove one variable, we do need to have the same coefficient. So notice that our coefficient in front of S are different. And same with R, 2 and 5, they're not equal, and we don't really care about the constant. So we do have to change one of the equations so it could eliminate one variable. What I'm going to do is I'm going to try to remove S first. Let's remove S. Remove S first. Okay. In order for us to remove S, the coefficient must be equal. Therefore, we need to find the lowest common multiple. So lowest common multiple for 3 and 4 will be 12. So we're going to multiply the first equation by 4. So I can make the coefficient in front of S equal to 12. For the second equation, I'm going to multiply by 3. So I can make the coefficient in front of S equal to 12. So let's rewrite this. Oops. I'm going to rewrite this on the side here. So you do expand it properly. So 12S plus 4 times 2 is 8. R equals 88. In the second equation, we have 12S plus 15R plus 123. Okay, So now we have a common coefficient. So we can subtract the second equation from the first equation. Okay, and also don't forget the bracket here, just because later on you're gonna deal with some negative coefficients, and if you don't have that bracket and if you forget to expand that negative into each term, then you might make some mistakes in between. Okay, so we'll talk about that case later, but for now, let's go on. So 12 minus 12 is 0. So 0s just is 0, so I'm not going to write anything down. We have 8r minus 15r, which is negative 7r. Equal sign comes down, and then we say 88 minus 128. This becomes negative 35. Next step would be isolating r. So we divide both sides by the coefficient in front of r. We have r equal to 5. Now we're going to sub this back into equation 1 or 2 to solve for s. It really doesn't matter which one, same reason. So 3s 2r 22. So I'm going to sub this r value 5 into the first equation here. Let's rewrite it. 2 times 5 equal 22. And this one's 3s plus 10 minus 22. And you take away 10 on both sides. 3s equals 12. And then isolate s by dividing it by 3. So s equals 4. Okay, so we're not done yet. Although we did define what those variables mean, we do have to restate them with correct units. So the price of 1 carton of strawberries is $4, S for strawberry. So the price of 1 carton of strawberry is $4, and the price, and so on to raspberries is $5. That's it for example 1. Moving on to example 2. Solve the system of two linear equations graphically. So first thing we need to do is rewrite those two equations into slope-intercept form, which is y equals mx plus b form. Let's start with the first equation here. I'm going to isolate y by subtracting 2x to both sides first. So we get negative y equal to negative 2x plus 8. And we divide both sides by negative 1. We get y equals to 2x minus 8. This is equation 1. Let's take a look at equation 2. We have the equation here, and I'm going to subtract 5x to both sides. We're left with negative 3y equals to negative 5x plus 21. Divide both sides by negative 3. We get y equal to 5 over 3x minus 7. And this is equation 2. So let's graph these two lines. Our y-intercept for the first equation is negative 8. I'm going to use blue for the first equation. So negative 8 is right here. And the slope is 2. So 2 up, 1 to the right. 2 up, 1 to the right, and so on. Okay. So this is equation 1. In red, I will graph the second line. y-intercept is -7, so we'll start right here and we go up by 5 and 3 to the right. Up by 5, 1, 2, 3, 4, 5. Okay, we already see an intersection here. 1, 2, 3, 4, 5. I'll do one more point. Okay, that should be okay. So, all right. I extended the line. Make sure to always extend it so I can see a little bit more than just that little chunk. All right, so this is equation 2. So we already found the intersection here, and the coordinate for this intersection is 3 and -2. So here you can state that the solution set is 3 and -2. Let's double check using elimination method. Let's rewrite the equation, the original equations here. The first equation and second equation is like that. So I want to eliminate y first, and first we do need to check our x aligned and y aligned. And they are, so we'll just continue. So we first need to find, in order for us to remove y, we have -1 and -3. So we do need to find the lowest common multiple. In this case, it is 3. So I will multiply the first equation only. I don't have to multiply the second equation because it's already 3. First equation by 3 here. So we're going to expand. So let's rewrite this first. We have 6x minus 3y equals 24. And then we're just going to write the same thing for the equation 2. We're not changing anything, so let's leave it at that. And notice that these two are equal now, so we can actually just remove it. So this is when negative sign with the bracket really matters. So if we were to rewrite this, this is basically saying 6 minus 5, right, which is x, -3 minus -3. So this is essentially saying we're adding the 3 to -3. So it goes 0y equals 24 minus 21. So we have 3. So we get x equals to 3. Right? So we're going to sub this x value into equation 1. So let me just rewrite this. I'm going to sub it right here. So 2 times 3 minus y equals 8. 6 minus y equals 8. Okay, so here's one step that I could kind of undo. So I'm just going to add y to both sides. So we have 6 equals 8 plus y. So I don't have to technically divide it by -1. So minus 8 on both sides. We get y equals -2. You can say y this way, the same order, just different side. So solution set is indeed 3 and -2. And we have verified it using elimination method. Moving on to example 3. So we were given 2 equations and we're solving for x and y, the solution set. So we'll do the same thing. We'll align these equations first, like that, and decide what we want to remove first. I would like to eliminate y first. So what I'm going to do is first check the coefficient in front of y. So I'll have -1/2 in front of the first equation, and the second equation is just 1. So I'm just going to find the lowest common multiple which is a whole number, by the way, or integer, not a fraction. So I'm just going to go multiply both sides by 2 for the first equation only. So this, when we rewrite it, this becomes 2x minus y equals negative 6. And then we're going to carry over the second equation here, just like that. And this time, we have the bracket around the second equation, but this time we're going to add the second two equations. The reason why is because when you look at the coefficient in front of y, that's a negative value. And when normally we subtract it. So if you take away a positive value, that means it's becoming more negative. So this time we want to add the positive value to cancel out the negative. Okay. So this one, we end up getting 2 over 5x. Yeah, because we're adding. And then 0y equals negative 6 plus negative 4, which is negative 10. We do need to solve for x, so we're going to multiply both sides by 2 first. So we get 5x equals negative 20, and you divide both sides by 5. We get x equals to negative 4. We're going to sub this back into equation 1. So I'm not going to rewrite it anymore. So negative 4 minus 1 half y equals negative 3. And we're going to isolate y. We add 4 to both sides. So we're left with negative 1 half y equal to 1. And we're going to multiply both sides by negative 2. Okay, so we get y equal to negative 2. So the solution set is negative 4 and negative 2. And similar thing from the previous section, we talked about what independent systems are. It's when systems that yield a definite result, just like this, when we have a coordinate, then this is called independent systems. The equation of an independent system yield intersecting lines and one solution. Let's take a look at part B. Same idea here. We're going to line up these two equations. And do not freak out just because you see fractions. Okay, so this is something we could actually remove as we rewrite the equation. So same thing, I would love to get rid of my y first. I mean, you can get rid of x first, it really doesn't matter, but you just gotta choose a different value. So lowest common multiple for y, so 4 and 2 over 3 would be 4. So I'm just gonna multiply by 6. Okay, so let's take a look. So first equation carries over. The second equation becomes 6x plus 12 over 3 is 4y equal to 42 over 3, which is 14. Oh, okay. So notice we have exact same equation. And if we actually subtract the second equation from this first equation, we get 0 equal 0. All right, so when you get an identity, like 1 equals to 1 or 0 equals 0, if that's an identity, it's always true. The statement's always true. So that means that this system is called dependent system. Okay, so this happens when there's infinitely many solutions. So this is when you can just state there's infinite solutions for solution sets. For part C, let's do this one, line these up. And this time I wanted to get rid of x first. So the lowest common multiple will be 2. So I'm going to multiply the first equation by 2. So we get 2x minus y equals 8. And the second equation carries over. And okay, let's take a look. So we have two equations, and then we're going to subtract the second equation from the first one because I wanted to get rid of x first. So if we do that, we're left with 2x minus 2x is 0. Negative y minus negative y is also 0. Okay, that's weird. And this equals to 8 minus 5 is 3. This is different from the previous part here, part B, because this is not true. 0 is never equal to 3. So this is not an identity. So if you get a false result like this, then the system is inconsistent. Okay, so which means there's no solution to this linear system. That's it for 9.2. I'll see you guys in the next video.